Okay, so now I will be going over question 12. So first, the two important concepts that are important in this question are tension and forces. Okay, so I'm going to explain the question, and as I go along answering it, I'll explain these concepts. So first, what I will do is read the question. A sphere of mass m hangs from two strings that each make an angle of 30 degrees with the horizontal, as shown in the figure above. What is the tension T in one of the strings? Okay, so first I will draw a picture of what's happening. So this, okay. So these are the two tensions, sorry about that. These are the two tensions that are holding this sphere of mass m. And it's making a degrees of 30 degrees with the horizontal. So basically, whenever we have an object that's hanging down, it will have a weight of mg. Now, so in this problem, we're trying to solve what these two tensions will be. Now, if the problem was set up like this, here, I'll just do an arrow here, and this was the weight, mg, these two strings would each have a tension of mg over 2. So it would be mg over 2 for this one and mg over 2 for this one, because it's just going up like that. So they would both be mg over 2. However, in this picture, since it's going at an angle of 30 degrees with the horizontal, it will not be mg over 2, and we need to set up the problem so that we can solve for these angles or for these tensions, and we'll do that using cosine and sine functions. So what I'm going to do now is I'm going to set up the problem to solve for these tensions. So first, since this is a triangle adds up to 180 degrees, this is 30 and 30, so 60, this is 120. But I'm going to set up a triangle so I can solve for the tensions on either side. So I'm just going to divide like this and do 60 degrees and 60 degrees. And then I'm also just going to set up these triangles, so then I have two 90-degree angles, and then this is 30 degrees on both sides. So as you can see, I've set up a 30, 60, 90 triangle, and this will allow me to solve for this angle right here, the hypotenuse, and find the tensions. So what I'm going to do, you can do sine, cosine, or whatever angle you wish to do. However, I'm just going to do cosine of 60 degrees, and the cosine of 60, cosine is adjacent over hypotenuse. So this angle, as I've shown before, or this right here going up, is mg over 2. Demonstrated that here. So mg over 2 is the adjacent, and then I'm solving for this, the hypotenuse. So I'm going to go over h. I'm solving for h. So first time I'm going to set this up is I'm going to go times h, both sides, h cosine of 60 degrees is equal to mg over 2. Then I'm going to divide by cosine of 60. And then I'll just do now cosine of 60 is 1/2. So I have h is equal to mg over 2. And then if we're dividing by something, we can multiply by the reciprocal. So I'll do 1 over 0.5, which is equal to mg, and then 2 times 0.5 is 1. So h is equal to mg. So the answer to this problem is D. The tensions that are holding up this weight here is mg. So in conclusion, this question showed important concepts of tension and forces. So an object will have a force of mg going down, and it needs, the tensions need to be holding up that force of mg going down. And in this case, with two angles at 30 degrees at the horizontals, we have mg and mg holding up that sphere of mg right there.